Hi everyone, welcome to this talk on a really back-end topic. I was wondering, using JSON with Postgres, I started using that a little bit just to save arrays as arrays in database, and then realized some details about it, and then started to dig into that and decided that actually to really dig into it, the best way to do that would be to prepare a talk on the topic, which made me go rather deep into it. A few words on myself. So my name is David Ullmann. I work for Drupal. I live in Bern, and I'm really more the backend developer. When we did this warm-up this morning, I was able to stand way over there. My Drupal account is super old. But actually, I didn't work with Drupal anymore since Drupal 5 or 6, and then did mostly Symfony. And they still do Symfony and backend applications. So what I'm going to talk about today is really about Postgres. It's not PHP specific even, but databases. So why would we want to store JSON in a relational database? So sometimes we have unstructured or semi-structured data that the backend doesn't really deeply need to understand the data structure. Maybe it's some front-end configuration and needs to know about, but the backend doesn't really care about the exact structure. Or even we just have something that is a serialized object in PHP, or something that we don't need the full denormalized thing in the database. If that's a nested big thing, it might also create a lot of tables and fields without much value if we don't query on those fields a lot. So kind of what I'm getting at is we can use Postgres or MySQL as our NoSQL database at home. So if we don't go too deep into all the NoSQL things, then actually storing JSON in a relational database can be a viable option. My experiments are available as a GitHub repository. The repository is called PostgreSJSON because I started off Postgres, and then there is this pull request that is actually quite nice because you see in the diff what changes when switching to MySQL. So in SQL we have a couple of things we can do. We can define a column as being of the type JSON. So this JSON-B, that's a Postgres thing. I will get to that in a second. For MySQL, it would just be JSON. You have MariaDB, then you're kind of less supported actually. You would store it in a string, and it's less powerful with the JSON options. I didn't really look deep into it, but my impression was it's really not a good option. To be aware, if you do this, if you store like a lot of data, actually your storage consumption is higher than if you would denormalize. Reason being, the database will store the keys of your JSON with each column, because each JSON document is stored with keys and values. So you repeat the keys everywhere. And if you would have a table with columns, you have the names of the columns once, and you have all the rows without names. Somebody calculated for Postgres that apparently if your values repeat or occur in more than one out of 80 rows, then going to columns would use less disk space on the database. The other caveat is that querying and joining into JSON like using things inside a JSON field, can be less optimized than if you have separate columns, because the database engine knows less and has less statistics about these data inside the JSON. So just be aware of that. It doesn't mean you can't use it, obviously, because otherwise that talk would not have much point. The JSON versus JSON-B thing that I mentioned. So JSON-B is a binary representation of JSON, and the idea is that Postgres can store the parsed JSON information rather than more or less a string, which makes it much more efficient for querying. On the other hand, if you store as JSON, it will allow you to do things that are not really JSON, like you can have duplicate keys. They won't be lost. If you use JSON-B, then the duplicate keys will be lost because it's parsed, and in JSON it doesn't make sense actually to have duplicate keys. It's not something that can exist. Also, the order of keys is not defined in JSON. If you use JSON-B, the order is not necessarily preserved. So if you rely on these kind of not really JSON things, then you should not use JSON-B. Now, when we have a JSON column, so that column called item, we can read data out of it. And the syntax for that is an arrow, and then you have the path inside the JSON document. Now, it already starts. Postgres and MySQL do it differently. In Postgres, it assumes that this is the path starting at root. MySQL says, hey, you have to start with $, because otherwise I don't know what you mean. I don't know why. Also, be aware, the single arrow extracts you a fragment of the JSON, which means if that author thing is a key and then the value is a string, what you get back is a string with quotes. So it's a JSON fragment that is a string. And you do a double arrow, it resolves that, meaning you just get a SQL string, not an SQL string with a JSON string in it. Which is, if you want to process the data, this is what you want. If you want, for example, to compare with some other piece of JSON, then maybe you want the fragment. Then I noticed that in Postgres, the double arrow function is about 2.5 times faster than the single arrow function. Now we can use this to filter on the data. So we can use information in the JSON column to say, hey, I want all the rows that has as author David. In MySQL, it's basically the same, but this. And then I did some measurements. Now, these are just numbers to give you an idea of scales, because I run this on my machine. It made a huge difference if it's plugged to electricity or not. Like, it's running on battery, it's saving energy, the processor is slower, the numbers completely change. So your hardware, your server, that's not my laptop, but what will be true is these numbers indicate relations. So if something is 10 times faster, probably on better hardware, it's still 10 times faster. And then I made data with 10, 100,000 rows, 1 million, 10 million rows, and made Postgres JSON column, Postgres JSON-B, and then a MySQL, and compared these, and then you have the milliseconds to query with this. Now, obviously, when you think about this, there is no index. We will be doing a full table scan. And what really sticks out here is if you have a lot of rows and you have this JSON-B, it's still like in at 1 million rows. It's kind of acceptable depending on your use case. I'm rather impressed. It's 150 milliseconds to go through 1 million rows of JSON data and check the field there. And basically, because MySQL doesn't have that JSONB thing, it's sort of close to what Postgres without JSONB would do. Maybe be a little bit faster, but not much. So I said we don't have an index. Obviously, if something's slow and we query, adding an index could be a good idea. So what we see here, so we can define an index. So that's just a table name. I made different tables for all the examples. And the index, we say, I do that on the author. So on that JSON path query. For MySQL, you then have to cast it to a jar 255 or something. Or you can use other length if you know the max length. You cannot use it without casting because then it would be text, and MySQL doesn't want index on text currently. Also, if your author is longer than that number of characters, it would not work the index. And what we see is the index is working extremely well. It doesn't make a difference anymore whether you have JSON or JSONB, obviously, because now the search happened in the index. We also notice that apparently MySQL somehow does that not as good. I don't know if that's because of the casting. I mean, the thing is, I also had to cast in the query then, because otherwise the two things are not comparable, and then it doesn't use the index at all. But that means the performance of that index is not amazing at all. Whereas in Postgres, I got it to instant responses even on huge data sets. Another thing we can do in both Postgres and MySQL is defining a generated column. So here I say, hey, I have an author column that is a jar thing. It's generate always, which means when you insert, also when you update. And we take the author again and store that into the database. And then we have this generated column, and obviously we can then do an index on generated column, which is what we compare here. So if I have a Postgres table with the index, that's on the JSON field indexed, and then we have the generated column without an index, which is currently Postgres also quite a bit faster. I mean, doing that without the index is kind of pointless, but then we add the index with really good performance again. And in MySQL, if you have to use MySQL for this, and you do this sort of index, you would really want to generate a column and then index on that, because now we get what we would expect from an index. We can also do more complicated searches on JSON. There's a contains operator. So I'm just kind of sticking with this example, but obviously the idea here is you can search for a whole fragment or a whole small JSON object, so you can filter on multiple criteria at the same time by just giving the database this object and say, hey, I want all the rows where the item column contains everything that is in my object that I'm searching for. We can also query whether some path inside the JSON column exists. You see here that you can't port code between Postgres and MySQL anymore. It's completely different. Basically, MySQL then uses for all these cases different parameters of the same method, while Postgres has different methods for everything, and also shortcut syntax that, I don't know, kind of I don't know, they kind of make sense, but at the same time, if you're not super familiar, I actually prefer functions with clear names, because then you just read the name and you know what it does. And otherwise, maybe you have to look up what does this question mark something actually mean. I did one more performance measurement on this contains operation, which it only gets interesting with the large numbers. So that's just for comparison from before, when we have an index on the JSON field. And if we do the contains check, also if we have the index, the contains check is not going to be any faster, even though the index would exactly help with that. Postgres doesn't realize that it can use the index here. And then I found that there's something called GIN. I think I have a slide right after, which repeats what the acronym stands for, I forgot. But that one makes some generic index. You don't tell it what, it just indexes the whole JSON data. And with that, you get like really amazing response times again on something that can be quite a complex query. And MySQL kind of really falls off. So if you have a lot of data, MySQL is not suitable for this kind of querying. Right. The generalized inverted index, which is to be able to do arbitrary JSON contains queries. It doesn't help with any of the other types of queries. It's really for that contains querying. Then I also looked at the insert performance, like how much does it cost if we want to have an index on these columns, how much slower does it get? So here, kind of the faster you get for the querying, kind of the more expensive it is to insert. And these numbers I did by running an SQL script that just generates data, so there is no application involved that would actually prepare data. So I think it really compares what the database is doing. And then most of the time, the bigger part of what you're doing, the bigger resources is actually the application fetching the data from somewhere and preparing it and then calling the database. So the inserting into the database is probably not the biggest part. But still, I found it interesting to see how that evolves. I mostly also was interested how it evolves if you, like each of these is 10 times more. And we see that it scales sort of linearly, not even one-to-one sometimes, but that means to me you won't have nasty surprises. Oh, if you have more than 1 million rows, suddenly it gets super slow to insert something new, because that was something I worried that might happen. I also looked at how big does the storage get of the database tables. And found it really does grow linearly. So the more data I have, the bigger it gets. There's no, even though my test data was a lot of repetition, like I just looped from 1 to 100 and then started over. So a lot of the rows have exactly the same data, but that does not get optimized away at all. And I also noticed with that inverted index on Postgres, at some point, like with the 10 million rows, the index was actually bigger than the table, which, depends on what you need, what your constraints are. But usually storage is much cheaper than computation and response time, so if it's more storage, that's usually worth it. Now we also have some statements to update JSON. We can partially update things in a JSON column. So here I I update the author field in the item to the value. And here I do need this double quote thing because I need to set it to a JSON fragment. I cannot give it a SQL string. It needs a JSON fragment. And then in Postgres, you can kind of control, do you want to just update but not create, or only create but not overwrite, and all kinds of flags. But actually, these queries are not faster than just regenerating the data on database level. In MySQL, we have similar, and the documentation claimed that they would optimize somehow and don't have to rebuild the whole JSON. I didn't see any velocity difference when running that, so I don't know, maybe the documents were too small to really see that, or maybe the difference is not that big. But still, it could be valuable if your application doesn't need to have to build the whole data and rewrite that, but can just push changes. And the same can also remove fields from the JSON object. You can also add things to have JSON validation with the JSON schema, which depends on what you do. I think if what you store is actually serialized PHP objects, for example, then you don't really need that because your data will be valid, but it depends what you need to do. Yeah, let's get to the conclusions. So actually, the SQL standards from 2016 and 23 define some JSON functionality. MySQL has a dedicated type for JSON. MariaDB doesn't. And a lot of the things are not really standard, or even if they exist in both, as you have seen, they can be differently in details. So I think for now, portable code is far away for JSON things. Let's say Postgres can really handle JSON quite well. You don't have to have a NoSQL database if all that you need from your database is storing JSON. MySQL has mostly functionality parity, but performance is really a lot worse. So if you want to do some querying in the JSON, then Postgres really is to be preferred. And then MariaDB is really limited in its support. It has its caveats to figure out how it works, but then if you have to learn a NoSQL database from scratch, that's going to be even harder and more caveats. If you use Postgres, use JSONB, unless something really prevents you from that. And if you have really essential data that you want to sort on, that you search on all the time, use dedicated columns or extract columns from the JSON. And then performance depends really a lot on how your data looks. So make sure that you test on real or at least realistic data, also quantities and the structure of the data. And don't take things for granted. And then if you have really a low number of rows, if you have 1,000 rows maybe, and you know it's not going to get much bigger, don't worry about the performance. Think about what makes you, what helps to work, to be efficient in coding. Yeah, and then if you need like really complex searches and whatnot, then maybe have a look at Elasticsearch or MongoDB. But I think you can really get quite far with these relational databases and JSON. And that's it.
Thank you, David. So I'm sure you have plenty of questions, but we are running out of time. So if you want to continue the discussion, I'm sure you're available to answer any questions. So we'll stop it here. Mm-hmm. Thank you, David.
Thank you.